All right, last thing in statistics we're going to learn about is residual plots. So residual is another word for leftover or difference. That's what the word residual means. All right, so to find the residual value, you take the actual value that's on that chart and you subtract the predicted value. So what happens when we get a list of data is we come up with a linear regression model or an exponential regression model. We use our calculators to do it. We've been practicing coming up with that little equation. The actual value is the number that's in the chart that you use to create this model. The predicted value is if you would plug in that same x value, what you would get out of that linear or exponential equation. All right, so basically when you plot all of the residual values onto one graph, you get another type of scatter plot that'll show you the relationship between the residual value and the x value. Now, the reason this is important is because if the regression model is the right model, so let's say you've picked linear, and if linear is the right way to do it for that particular set of data, the residual plot's going to have a very random scatter. The dots are just going to be all over the place. There's not going to be any particular pattern to them. If the residual plot that you get, if you say, like I said, pick linear, and you use a residual plot and you get some sort of pattern, then the regression model that you use is not a good model. It's not the right way to do it. So we've used R before to see whether or not it's a good fit for the data, and R is good, but residual plots are foolproof. If you get a pattern, that's bad. You've used the wrong model. So if you pick linear, maybe try exponential. And then if you get something random, that means it's good. It's right on target. So the worksheet you're working off of is this one, and you should have used what we just talked about in order to fill in this top part. So let's look at some examples. So this says we use a linear model. It says determine if the linear regression model is appropriate by looking at the graph of residuals. All right, so the difference between them goes anywhere from -1 to 0.5. It gives you a baseline at 0. And you see how perfect this little pattern is? It looks like a really nice pattern. The pattern is bad. Okay, random is good. All right, so this has a pattern, so it's not a good fit. Okay, this one. This kind of doesn't look like it has a pattern, but it really does. This is called a fan, and if you look at it, it almost looks like it could be a fan if you were to draw it in. All right, it kind of looks like almost a sideways trophy or something like that. The fan is a pattern, and that's not good, so not a good fit. Fan's probably the hardest pattern to pick up. This next one clearly has a pattern. It's got that U shape, so it's not a good fit. And this one, even though it slopes down, you got this one random guy out here, it's not in a perfect line. There's no zigzag or anything to it. So this is considered random, especially because of this one. So this is a good fit. Okay, so pattern, not a good fit. Random, good fit. So we're looking for randomness. So how do you create a residual plot? So the first thing you have to do is use a regression model. So this one's already given you this regression model. The regression model came from this set of data. So what we have to do for each of these is plug in these numbers to fill in the predicted amount. So if I were to use the model and ask it for what happens at 28, what happens at 36, what happens at 17, what happens at 23, and so on, that's the numbers that are going to go in here. So what I'm going to do is I'm going to go to my table function. Okay, I'm going to go down to edit function, and I'm going to clear this out and type in the equation. So 1.73 x minus 0.96. I'm going to put that in, and I'm going to tell it to ask. I want to ask for particular x values, these x values. So I'm going to tell it to calculate, and I'm going to ask for 28. So that's 47.48, 36, 61.32, 17, 28.45, 23, 38.83, 41, 69.97, 22, 37.1, 37, 63.5, and 28, 47.48. So if I were to plug in each of these values for x, these are the numbers I would get. Your residuals is the observed, what actually happened, minus the predicted. It's always this column minus that one. So 30 minus 31.9 is going to be negative 1.9. 47 minus 47.8 is going to be negative 0.48, 56 minus, I'm just doing it in my calculator real quick, 56 minus 61.32, negative 5.32, 27 minus 28.45, negative 1.45, 23 minus 38.83, 41 minus 6, no, wrong number here. I don't use 23 to subtract. I've got to use these values over here. So you can almost use your calculator to cover up those. See, I messed up just now. So 35 minus 38.83. 35 minus 38.83. Let's get this right. Negative 3.83. 65 minus 69.97. Negative 4.97. 41 minus 37.1, 3.9, 73 minus 63.5, and 54 minus 47.48, 6.52. All right, so step 2 says your second column minus your third column. So second column minus third column equals fourth column. So that's all we did. So step 3, we're going to plot these points. So here I've got negative 8 to 12, and then I've got 10 all the way out to 50. So at 32, I'm at negative 3.4. So at 32, negative 3.4, so almost at negative 4. 19, I'm at negative 1.9. So not quite to negative 2. 28, I'm at positive 0.5, just about. 36, negative 0.53, so halfway between those two. At 17, I'm at negative 1.45. At 23, I am at negative, almost negative 4. At 41, negative 5, just about. 22, I'm at positive almost 4. 37, I'm at positive almost 10. And 28, I'm at positive 6.5. All right, that is pretty, well, that kind of looks like a fan. See how it fans out from one point? All right, so this is not a good fit because it is patterned like a fan. All right, that's how you do a residual.